So what we have here is a demonstration of how CC-Link IETSN and time-sensitive networking provides very deterministic communications. So we have two Mitsubishi PLCs, we have a master station and a remote station. We have an HMI that operates the demo, and we have two Moxa switchers which connect the network together. We can also apply artificial load to the network to simulate real-time conditions. What you see right now is that we have CC-Link IETSN allowing the communications between the two PLCs, and the two wheels down here are being spun by the servo drives under the control of the PLCs, and we also have a ZIC motion sensor down here which is monitoring the rotation of the wheels. This is the master station, and it's spinning its wheel, and it's basically over the network. It's telling the remote station, spin your wheel in the same way. We're using a stroboscopic system to make those two words appear stationary, similar to how, for example, a record turntable works. So you can see right now, the master and remote are exactly aligned because we've got very deterministic communications using TSN. If we were now to switch this to using normal Ethernet without any kind of industrial protocol, you'll see something very different happens. Now we've changed to just using Ethernet, the color's changed, and we can see now we've totally lost synchronization between the two wheels. The word remote is now totally misaligned with the word master. We can take this one step further and apply a different kind of industrial Ethernet technology, and we can see we still don't have alignment between the two wheels because this is not using time-sensitive networking like CC-Link IETSN uses. We switch to another different kind of industrial Ethernet technology. Now we're using the other type, but once again we can see we don't have synchronization between the two wheels because we are not using time-sensitive networking. So this is a very clear demonstration of how time-sensitive networking, and also gigabit bandwidth in this case, provides a very deterministic method of communication between different PLCs. If we go back to CC-Link IETSN, now we have the precise synchronization between the two wheels because we're using TSN again. So one final thing to consider is how in a real-world application we have real-world traffic on the network, so we have a certain amount of network load. We can apply a simulated network load by pushing this button here. We see how the network traffic starts to increase, applying simulated network traffic to the network. But what we can see down here, because we're still using CC-Link IETSN and the time-sensitive networking, the wheels are still precisely aligned because even though we've applied network traffic in a simulated way, it hasn't affected the performance of the network, so we still have very deterministic communications. Final point to consider is how CC-Link IETSN also offers gigabit bandwidth. This means that now you have a huge amount of data handling capability, and so this is very suitable for handling Industry 4.0 applications. What this means in practical terms, say for example you're running a high-speed packaging machine and you've got lots of different mechanical processes happening in the machine, you need to be able to know that events in the machine happen exactly when they are supposed to, so that machinery isn't getting in each other's way, you're not risking machine damage, you're not risking damaged products, or even just loss of quality. By using these kind of deterministic communications with CC-Link IETSN and these kind of motion control systems from Mitsubishi Electric, we can make sure that we can deliver that kind of performance.